Good morning, everyone. So this video, we've got Henry here as well, our documentation lead. And this video is going to be all about networking in ArduPilot. And so what we're going to be doing is demonstrating some of the latest features we've got in some pending work that I've been doing with Sid and Tom on ArduPilot network support. So in particular, I'm going to be showing some of the features that we've got with this pull request that is currently pending that adds the ability to do networking over PPP on serial ports. And what this does is this brings full networking, full IPv4 networking capability to ArduPilot on boards that don't have a Ethernet connector. So we've had support for a few months now for networking on boards, for example, like this one, which this is a CUAV Pixhawk 6X, and it's got a little Ethernet port on the side of it, and I've got that plugged into a lovely little adapter from BotBlocks that brings it out to a standard Ethernet patch cable. And so that allows you to get standard networking with ArduPilot. I'll be showing some of the features of that, but I'll also then be showing how to get most of the functionality or the same functionality, just not quite as much speed by using PPP over a serial port. And I'll be demonstrating that on a Cube Orange. So just to get started, I'm going to show the setup I've got on my desk. So my apologies with the camera movement. So what I've got here, you can see that I've got a Cube Red here. So this Cube Red is set up with a Ethernet port here. And so it's connected using the little, I'm really terrible at pointing the camera, apologies for that. It's set up using a little Ethernet port that comes on the Cube Red and goes out to one of these BotBlocks adapters, and that goes into my home network switch. Then I've got a Cube Orange here. So that Cube Orange is attached here via the TLEM1 UART. Notice I've got all 6 pins of the TLEM1 UART connected across to this Raspberry Pi 4. And on the Raspberry Pi 4, I've got 5 of the 6 pins connected. The 6th is the 5-volt. I'm not using the power supply, so I don't need that. And then the other pins are connected to give me a UART with hardware flow control. And this Raspberry Pi 4 is also connected to my home network using this blue Ethernet cable I've got here, like that.
Cridge,
all right.
Might interject just
sure.
That the basic Ethernet networking capability is already in master.
Indeed.
There is a wiki PR 5656 that you could read, and it gives figures and explanation of how all that's connected and the topology of networking in ArduPilot and web servers and so forth and so on. That might be a good place to read up if you're not familiar already with the master networking that's already in there. And then this is an extension basically to provide networking support using point-to-point and PPP and with other H7 flight controllers that don't have Ethernet built into them.
Indeed. So what I've got here, I've got MavProxy connected to a Cube Red and a Cube Orange. This is MavProxy connected on USB to the Cube Orange in the top window here, and here it's connected to a Cube Red in the bottom window. And I built both of them with this Enable Network Tests option. What that does is enables some benchmark tests for networking. And so I'll just show you what's happening with that one. So I've got, this is the Cube Red. And I'll just pop into the Cube Red's parameter editor and do it up like that and look for net underscore, and you will see that there is a net tests option, and I'm going to put net tests to 4, and what that will do is enable what's called a TCP discard test, and that will do bulk TCP transfer to the TCP discard port on my laptop. And so my laptop on my home network is 192.168.2.15. So what I'm going to do is start by rebooting that with that network tests enabled. And I'll also note that this QBread is set up to use DHCP. So it's got net DHCP to 1. So it's using my DHCP server on my home network to get the IP address. And you can see here that it got an assigned an IP address from my DHCP server of 192.168.2.202. And this is now showing the throughput that I'm getting. And what you can see is that since we last had a look at this, we're getting better throughput on Ethernet than we used to get. So we're now getting about 8.6 megabytes per second of TCP throughput, which is pretty good on a 100 megabit network. The theoretical limit would be 10 megabytes a second, but there's always going to be a little bit of overhead. And so we've just tweaked the LWIP options to give us a little bit more throughput. And so we can now get that 8.6 megabytes a second. And of course, we can set this up to enable network ports to come out. So I'll just turn off the network test now, because we don't need to be flooding my network with that network test the whole time. Yeah. So I'll...
Tridge, this is on the red, and it can be using master, right, as it is
That's
right now.
But it's faster with the new PR. So we got about 6 megabytes a second with what we got in master. Now we can get about 8.6.
So the firmware you're using on both of the ArduPilots is basically master with this PR merged in.
With this PR added, that's right, yes. Okay. So now I've also got enabled what was a feature that's already in master, where we can do forwarding. Actually, this isn't turned on that one. It is turned on the orange. And I'll demonstrate that in a second once we've got PPP. All right, so that's our basic support. That's what's in master. It's just a little bit faster. Now I'll start talking about the PPP link. And the reason we're putting the effort in for PPP is that most flight controllers that people have at the moment don't have an Ethernet port. And we wanted people to be able to get the full capabilities of networking on existing flight controllers that only had UARTs. And so if you've got something like, a Cube Orange or I don't know, a Pixhawk 6C or any other H7 based flight controller, and it's got a UART on it, then you can use that UART to get networking. So what we
do... With flow control.
Yeah, preferably with flow control. You can actually make it work without flow control, but it sometimes gets quite slow. It does work. But if you put a lot of data through it, then it'll get quite slow. That's something that we're working on. All right. So if I show you the settings on my Cube Orange, this is the Cube Orange, and all I need to do is set net enabled to 1, and then the most important thing I need to set is my serial settings. Now, I have this connected on serial 1, so telemetry 1. So I have a cable cross-connected between the Cube Orange and the Raspberry Pi, where the transmit pin on the Cube Orange goes to the receive pin on the Raspberry Pi, and vice versa. And I've got the RTS pin on the Cube Orange going to the CTS pin on the Raspberry Pi, and the CTS pin on the Cube Orange going to the RTS pin on the Raspberry Pi. And I can show you what those pins are in a second. So then I need to set this serial 1 protocol to 48. Now 48 is the serial protocol number for PPP. So this is what tells ArduPilot to establish a PPP link on that serial port. So now the baud rate I'm setting is 12.5 megabit per second. And that is the absolute fastest baud rate that an H7 STM32 can go at. The reason for that is the maximum clock that an H7 can use on its UART is 100 megahertz. And the H7 has to use at least 8 times oversampling on its UARTs, which means its clock needs to be 8 times faster than its baud rate. And 8 times 12.5 megabit is 100 megahertz. So it just physically cannot go any faster than that 12.5 megabit, which is already pretty darn fast, given people normally consider, 921.600 to be a fast UART. In this case, we're running 12.5 times that, or 13 times that. And so we're really pushing this UART at very, very high speeds. Okay, so now on the other end, this is my Raspberry Pi 4. And this is a Raspberry Pi 4 that arrived in the post yesterday, and it just has the standard Raspbian install that came with the Raspberry Pi 4. And so I've got this Raspberry Pi 4 connected on my local area network, and then I've got a UART. Now, I'll just show you the UART setup. So I need to go to boot config.txt, and I had to add 2 lines into the boot config. That's these 2 lines here. And I'll just raise the font so it's easier to read there on YouTube. The key one is I have to put this init clock UART to 200 megahertz. Now, the default clock on the UARTs on a Raspberry Pi 4 is 48 megahertz. But on the Raspberry Pi 4, the chipset on the Raspberry Pi 4 can only do, has to do 16 times oversampling on UARTs, which means the maximum baud rate you can do on a UART is 1/16 of the clock. That means with the default clock on the Raspberry Pi 4, you can't do more than 3 megabit, because 3 times 16 is 48. So what we're doing is we're pushing this up to 200 megahertz UART clock. And if we divide that by 16, that gives us 12.5 megabit, which is the same as the maximum baud rate on the H7 on the Cube Orange. The next line we need to do is got to set this DT overlay. So we just add that line there, which says I want to enable UART2 on this Raspberry Pi 4, and I want to enable hardware flow control lines. So I say I need a 4-pin UART, so receive, a transmit, a CTS, and an RTS. That's what you get if you put this comma CRTS, CTS, RTS at the end of this DT overlay line. And DT overlay stands for device tree overlay. This just tells it to load the device driver for UART2. It doesn't have to be UART2 that you use. You could use UART3, 4, 5. You could use UART0 or 1, any of the UARTs, as long as you've got it set up with hardware flow control to get the maximum speed. So we do that, and then we reboot the Raspberry Pi, and then the Raspberry Pi is now capable of doing 12.5 megabits. All right. And so next thing I need to do, the version of PPP, you've got this PPP daemon, and so actually I need to run that as root, but sudo PPP daemon -h. So you've got this PPP daemon, right? And the version that comes with the Raspberry Pi is 2.4.9. Unfortunately, 2.4.9 can't do 12.5 megabit. It says unsupported baud rate. There are workarounds for that, but the simplest thing to do is to update your version of PPP daemon on the Raspberry Pi to the latest version. And so if you have a look at this PPP project, so github.com, PPP project/PPP, and many thanks to my old PhD supervisor, Paul McKerris, for maintaining this PPP daemon. So if you clone that and build it, you don't need to build it with any particular options, but you need to build that, and that'll get you the 2.5 version of the PPP daemon, and that is capable of doing the full 12.5 megabit. So if you're happy to run at a slightly lower speed, you can just use the one that came with the Raspberry Pi. But if you want to be a speed demon and get every bit of speed you can out of your Raspberry Pi and Cube Orange, you need to get this latest version here.
Could you possibly put that on a file server and link it in the PR?
Indeed, we could. So this is now the version that has support. So this is a slightly newer version. And so this is PPP daemon version 2.51 dev, because it's off the master from GitHub. And this one does support the 12.5 megabit baud rate. All right, so now we need to see, how do we start PPP daemon? Now, I've been starting it in debug mode. So let me just explain this, these options. And again, once we get this PR merge, we'll put all of this in the wiki. But we'll need to run PPP daemon, and this is a debug option where it'll put a whole lot of debug stuff to the console so we can see what it's doing. But I'll just explain what it's doing here. First of all, I'm turning on debug so I can see what it's doing. I'm telling it to connect to TTY AMA2, which is UART 2 on this one because we added that in the overlay to add UART 2. Then I'm telling it to run at 12.5 megabit. That's why it's 12,500,000, which is the baud rate we're setting up at the other end. Now I'm setting the IP addresses that I want to use. So the local IP address, which is what the IP address of the PPP link is on the Raspberry Pi, and the remote IP address, which is what the IP address will be on the Cube Orange. And I've chosen those IP addresses to be addresses that are on my local network. I use a 192.168.2 network at home. And by choosing addresses on that network, that means that the Cube Orange will appear on my local network, will be accessible from my laptop and other computers on my home network, which is convenient. But really, you can choose any two unused IP addresses here. I'm telling it I'm not going to use any authentication because I've got, it's a trusted device, my Cube Orange. I don't need to authenticate when talking to it. I'm doing a note attach. That's just so it sits there in the terminal and shows me the debug messages. This turns on hardware flow control. So it tells PPP daemon to use the hardware flow control pins to talk to the UART. This says local. That means it's a local UART. I'm not using a modem. So it's not going to do modem control signals when talking to the UART. I'm turning on proxy ARP. Now, what that does is that makes the PPP daemon answer address resolution protocol requests from my local area network for the remote IP address on the Cube Orange. And that's what allows other devices on my network to see the Cube Orange as though it was directly attached to the network, which is very convenient. It means I can then go with my web browser and go directly to the Cube Orange, or I can ping it, or I can download log files directly to machines on my network. And finally, the K-tune option, that tells PPP daemon that it's allowed to adjust my kernel parameters to make proxy ARP work. In particular, what it will do is it will turn on the IP forwarding options that are needed to allow proxy ARP to work. All right, so what I'm going to do, so we've got all of that there, and this will go into the wiki later. I'm going to reboot my Cube Orange. So it's starting up, and then I'm going to start PPP on the Raspberry Pi, like that. And probably I'm already running it. Yes, okay, I was already running it there. So now I'm going to run it again. There it is. So it's started. And this is it negotiating with the Cube Orange. And you can see it's found an interface for proxy ARP, and it's now assigned these addresses. And you'll also see here on the Cube Orange, it then announces that it got a address, right? This is something worth looking at here. This is a critical deadlock. Very experimental code, this, but I'll have a look at that in a little while. All right, so that's got ourselves an IP address on the Cube Orange, which means we can now access this address, this remote address on the Raspberry Pi from on the Cube Orange from the Raspberry Pi. So there I am pinging the Cube Orange from the Raspberry Pi. Now, because I did proxy ARP, the web server installed on because I've got the little script with the web server, I can connect to the ArduPilot Lua-based web server. So this little web server that's showing the time ticking over is running directly on the Cube Orange. So it's got its own little web server built into the Cube Orange as a Lua script. And so if I go and have a look at that Lua script, I can actually go and have a look at the SD card via a web browser, and I can go and have a look at the scripts. And this is the little web server that I've got running on the Cube Orange. So this is the web server serving its own source code, which I think is quite cute. into a web browser. And so this little script you have to put into the APM scripts directory to get the web server running on the Raspberry Pi. And again, there's some documentation that goes along with this Lua script. Now, this also gives us very convenient access to our log files. So there's all the log files on the Cube Orange, and we can access those log files via the a web browser. So if I click on this file here, then it'll start downloading, and so there it is, download, 3 seconds, 2 seconds, and it actually downloads quite quickly. So if I test it on here with wget, which shows us the performance, so this is fetching a log file from the Cube Orange across the PPP link. And if I download it like that, you'll see that I'm getting 770 kilobytes per second. In fact, gone up to just over 800 kilobytes a second there, fetching that log file. Now that's actually faster than fetching the file via USB. So I could try and download that same one over USB. So log download 12, that same log file, and you'll see that it's getting about 380, 390 kilobytes a second. So we're actually getting nearly twice the speed downloading logs via the web server than we are directly over USB. And that's because of the overhead of Mavlink. So Mavlink has a bit of an overhead associated with it and doing various CRCs, etc. Whereas the web server has a rapid access method of pumping data out through sockets from the file system, which makes it considerably faster. And so this is going to be very convenient. Now, in this particular case, I was fetching that log file to the Raspberry Pi. But the more interesting case is actually to fetch it onto my laptop, right? And so what I'm going to do is download that. And the reason that's interesting is because imagine you have a companion computer on your aircraft which has a high-speed network, something like a HearLink or similar, or a Silvus radio, other high-speed IP-based radio, and you connect it to a companion computer, then you will be able to download the logs remotely onto your ground station twice as fast as you would be able to get them by walking up to the aircraft and plugging in USB. So I'll just grab the URL for that same log file again, and I'll go and fetch that onto my laptop, which means it's being, it's actually routing it from the Cube Orange to the Raspberry Pi, then forwarding that connection via the proxy ARP mechanism down to my laptop. And so I'll just fire up Wireshark here so you can see what's going on. So I'll start a Wireshark session and then download here. And you can see I'm getting 750, 700, getting up just over 800 kilobytes a second, downloading forwarded with proxy ARP via the laptop, and which is going to be really, really useful. So that will mean if you've got this high-speed radio link, which so many people have these days, like a HearLink or similar, then you'll be able to, in a web browser on your hand controller, one of the little Android-based hand controller, you'll be able to go to the ArduPilot web server and then click through to the logs and download a log, and it'll actually come down twice as fast than it would come down if you went and plugged in USB. But you've got it remotely. It also opens up the possibility of us backing up logs automatically to the cloud, transferring them in flight, etc. And it's quite low overhead. The CPU cost of doing that fast download is very low because TCP has a very low overhead, which means the ArduPilot is not at all overloaded doing that fast download. All right, so we're nearly done. I know it's a lot to take in. So there's one final trick I'll show you that this has got. So if you're a developer, I'll just kill off these links to the cube red and the cube orange and things here. And I'll show you something you can do here. I'm now going to run sim vehicle, but I'm going to, with sim vehicle, do enable PPP, because you can actually run all of the networking code, all of the lightweight IP, so LWIP and PPP in CITL. So I'm going to fire up this with sim vehicle, and what this is going to do is build CITL with PPP support, and then I can run PPP over a TCP socket, because ArduPilot CITL Simulator presents its virtual UARTs as TCP sockets. It could also do UDP and other mechanisms. This particular case, I'm using the default TCP socket. And I'm going to connect to 127.0.0.1 So that's serial 5. So the default UARTs in ArduPilot are serial 0 for is 5760, serial 1 is 5761, etc. In this particular case, I'm setting up serial 5 as running for PPP, and you'll see the parameters in a second when I fire that up. And just taking a bit of time to, should have pre-compiled it before this video. Nearly there. All right, there it goes. Great. And if I set serial 5, so it's set to, now the baud rate doesn't matter here because it's a TCP connection, but it's serial protocol 48. And what I'm going to do now is fire up, that's the PPP daemon talking across that TCP socket, right? And it's now got an IP address of this 192.168.14.13. I can now ping that, and I'm now pinging into my CITL environment via LWIP running over a virtual UART. And the reason that's useful, we are getting some duplicated packets here, and I haven't yet sorted out the reason why we're getting duplicated ICMP echo packets sometimes. Something to look into. But it's a great way of debugging, because that means that I can actually debug this. So I could, for example, put a break on TCP input, and there's no TCP, there you go, TCP. And so I can actually single step through the whole LWIP stack and see exactly what's happening and debug the code with a much more comfortable debug environment than running on real hardware. All right, so that was probably a lot to take in, and this video's, as we mentioned at the beginning, not really aimed at end users. This is aimed at other developers, and I'm looking for other people to try out this system to see how it works on their systems. It'd be great to try it on, for example, an NVIDIA Jetson to see what sort of baud rates we can get. Can we get the full 12.5 megabit on an NVIDIA Jetson? Can we get 12.5 megabit on a Raspberry Pi Zero, which is a very, very small system? One final thing that we're going to be working on is getting PPP running on something like this, except hopefully a much smaller non-developer version of this. So this is an ESP32. And so this has got a built-in Wi-Fi and Bluetooth, and it's also got high-speed UARTs. So the plan is that we install PPP on this to act as a PPP to Wi-Fi gateway. And these are very, very cheap. These are less than $20. So you could get one of these devices, and there are much smaller versions of these. This is the full developer one with lots and lots of pins on it. You get a small version of one of these and connect it to the UART on your flight controller, and that will give you full Wi-Fi networking on your flight controller over a UART. So very exciting, lots of things to play with, and hopefully that introduction will get people started. Any questions, Henry?
No. So the standard Raspberry Pi 4 comes with all the Linux system and the PPP module that you need,
It
except you need
does.
to upgrade it.
Yeah,
And
upgrade
you're
to
going to,
PPP if you want the highest possible baud rate. Yes.
like I said, it might be nice if you did the upgraded daemon on
As a
one of your,
package. Yeah, indeed. It'd be
yeah,
nice to do a little package for it. Yep.
yeah, and just link it into the PR so the developers, when they merge the PR in, could get that and upgrade whatever. So
Sounds good. All right.
great.
All right. Well, thanks for listening, and I hope you enjoy the new networking features we're getting in ArduPilot, and we will do more updates as we get more features in the future. So happy
Thanks.
flying, and have a great day.
Take it easy.